Professor Dr. N. Ganesh is working as a senior faculty, Department of Computer Science and Engineering, SRM University, City Campus, Vadapalani, Chennai. He has more than 12 years of undergraduate and postgraduate teaching experience, which includes 5 years of research experience. He has trained many corporate batches on technologies such as mainframes, Application Systems 400, SAP, ABAP. He has published 10 articles in both international and national journals. He has presented several papers in both national and international conferences. He has written 4 books which are prescribed in Anna University affiliated colleges, SRM University and Bharat University. His research interests are software engineering, data mining and cloud computing.
Welcome to UGC lecture series in computer science. We are going to see a series of lectures in the subject operating system. This subject is for the students studying in their 5th semester of their BSc degree program. The subject operating system belongs to paper number 8. In today's lecture, we are going to see few topics from unit 4. In unit 4, there are several topics in which we are going to see topics on the file system structure and the allocation methods. So, this today's contents we will be having the following topics: file system structure, file system implementation, directory implementation and the allocation methods. Now, what is a file system structure? In our previous lectures, we have seen about the file system and what a file is, what are the different types of file, what is a file attribute and what are the different operations that could be performed in a file. In one other lecture, we have seen about the disk structure. What is a disk? What is a directory? How the files have been organized, arranged in a directory, how the directories have been arranged in the disk, how the disk has been arranged, how it has been arranged in a logical fashion. So, all these things we have seen in the previous lectures. So, in this lecture, we are going to see how the file system has been structured, how it has been allocated, what is the allocation method and how this allocation method has been put in a file as well in the directories. So, now as a first part, the file system structure, here what is a file structure? File structure is a logical storage unit. It is a collection of related information. This file system resides on the secondary storage or the disk. Disk is nothing but the hard disk. Secondary storage is a hard disk, whereas main memory is a main storage or a primary storage is a RAM memory. So, in today's lecture, we are speaking only with respect to the secondary disk, the secondary storage, that is the hard disk. How these files have been allocated, how these files have been stored, how these files have been organized into. So, we speak only with respect to a secondary disk. Then, in this file system structure, the disk provides rewrite and random access. So, this I/O transfer performed in blocks of sectors, usually it will be of 512 bytes. And then we have a file control block and a device driver. File control block it's a storage structure consisting of information about the file. This file control block, I suppose you would have seen in our earlier lectures about the process control block and several blocks within an operating system. So, similar to a process control block, this file control block contains all the details required for a particular file. All the contents and all the structure details of a particular file will be stored in this file control block. So, now we will see how these files have been arranged. These files have been arranged into different layers. So, this file system has been organized into different layers. So, this is how it looks like. A layered file system looks like this. Here you have an application program, and this application program you have a logical file system, and from the logical file system we have a file organization module, and then from the file organization module we have the basic file system, and from basic file system we have an IO control. IO control is nothing but an input and output control, and this input and output control is been given to the devices. This application program is nothing but the programs that has been used by the user, the executable programs and all other programs that has been used by the user, you call it as an application program. And from the application program you have a logical file system, LFS, and from the logical file system we have a file organization module, wherein how this files have been arranged logically, or how this file is been arranged in a structured manner. That is what is the file organization module is. Then about a basic file system. What is the type of file system it has? That says about the basic file system. And then about the IO control. IO control is when a particular application program, supposing if I want to, if you have opened a document file, if it is of 10 pages length, if you have contents for 10 different pages, and if you want to print the content, then you press a Ctrl P button hotkey, or you go to a file menu, and from the file menu you click on the print, you click on the number of pages to be printed, number of copies to be printed, and you give OK button. You press an OK button. So the print is said to be the IO control. IO is the input and output devices. So printer is said to be one of the output device. Keyboard is an input device. So this IO control comes under this basic file system. And press the print button, or when you give a print command, then it goes to the device and it checks whether the device is on or off. And supposing if all the papers have been loaded into a printer, then it automatically prints the contents. Supposing if it is not on, consider if the printer has been switched off, or the printer is switched on and there is no paper. You get a pop-up message stating that load paper in A4 cassette, or load paper in the manual fleet slot, because no paper exists, or check the cable, check whether a printer is turned on. So you get such message, which means that it has not been turned on, or paper has not been loaded properly, or check whether paper has been jammed into a printer. So you get such messages. So these messages you get one and only after this IO control goes and checks into the devices whether the device is working or not, and then it responds back to the IO control, and then it is given to the user based on the basic file system. So this is called as a layered file system. In the layered file system, we will see about we will see the different file system layers. One is about the device drivers and about the basic file system. This device drivers manages the IO devices at the IO control layer. So you have a read drive, you have a cylinder. Say for example, this particular file, this particular Word document is being put under a directory, under a folder, inside a folder. That folder is being present inside a drive, D drive consider. So the D drive, where will it reside? It resides in the hard disk. In the hard disk, in the sense, where in hard disk it will be residing? It will be residing in one particular cylinder. So usually there will be a cylinders of size of 72 cylinders or 32 cylinders, so on. So let us consider it is residing in that cylinder. So how this file system, how the files are being tracked from the cylinders is said to be the device drivers. So tracking and getting all the details of the file requires a driver folder, and that is called as a device driver. An example is given over here. Commands like read drive cylinder 72 track to sector 10 into memory location 1060. It outputs low level hardware specific commands to hardware controller. Then we have a basic file system. Basic file system gives commands like retrieve block 123, which translates to device driver. So from the device driver, what happens is that as block number 123 will be searched first. This device driver searches block number 123 and it retrieves the contents from block number 123. That file gets retrieved. So the command that we give us retrieve block 123 means it retrieves the file. So that is one file system. So it buffers the hold data which is in transit. It caches hold frequently used data. Cache is nothing but a buffer memory, a temporary memory wherein we store all our data. Taking the contents from a temporary memory will be faster when compared to taking the contents from the hard disk directly. See, you have the same content that has been put on the hard disk, and the temporary file, when the file is in access, it gets stored into a temporary file, and that is the reason if you have seen working with MS Word, when the file is in open, you could find a temporary file with a name dollar symbol. You will be seeing a hidden file with a dollar symbol and the same file. So which means that this gets stored into a temporary file, and which can be easily retrieved. And when only when you close the file MS document file, this temporary file will be automatically, it will get deleted. Otherwise, this will also be stored till the file is open. This temporary file will also be stored in the same directory of the file system. Then the other things are the file organization module. The usage of file organization module is to understand the file logical address and the physical blocks. Logical file system manages the metadata information. What do you mean by metadata information? Metadata is data about data. It has all the information about the data. And in our Unix operating system, you would have known about this inodes concept. Inodes has all the data information about the particular file. So inode is one which has been stored in the kernel, and that has all the information about this data. So in our Windows, we have a metadata. It is nothing but data about data. Data about data is having the entire information about a particular file. Then in this file system, we have different files as UFS, FFS in the case of Unix, and in the case of Windows, we have FAT file system, file allocation table of 32, and NTFS, new technology file system, and as well we have other file formats systems such as the removable drives such as floppy drive, compact disk or the CD drive, digital versatile disk, Blu-ray device, and these are the devices that are supported in Windows. And Linux has more than 40 types with extended file system with extension of ext2 and ext3 as such. And we have other file systems as well in the distributed file system. And nowadays we have the newer file systems such as ZFS. ZFS is a zettabyte file system which is being used in the Solaris operating systems. As well, we will be getting the other file systems as the Oracle file system, that is nothing but which has an extension with ASM. So that is called as an Oracle file system. Then now let us see about a file control block and what are the details that are stored inside a file control block. So inside a file control block, we have these things such as file permission, file dates, file owner and its group, and then file size and file data blocks or pointers to file data blocks. We will see more details about this file control block after the break. Welcome back after the break. We were seeing details about the file control block. So now we will see about the file control blocks, how the file control block looks like and what are the contents available inside a file control block. So we have inside a file control block, we have the file permissions to whether to read or write or rewrite or no permission. So all these things are being placed inside this file permission. We have the file dates, when this file has been created, when it has been accessed or when it has been modified. Write is when it has been modified. We have a file owner name and the group of files. And then we have the file size, what is the storage of size. And then we have a file data blocks or the pointers to file data blocks. File data block in the sense as, supposing if there is a connectivity with respect to other location, then that is a pointer to file data block. What is the last read content, or till which line the file has been read at the last, and till which line that file has been written at the last. So all these things are being stored under this file control block, under this file data block or the pointers to file data block. So this is a typical file control block. So now let us see how this file system is being used inside the memory, or how the data are being organized from the file system. Let us see a diagrammatic viewpoint. Over here we are opening a file. So when we open a file, this is said to be my directory, my folder, consider. So here you have a file. So when you open the file, immediately the command goes from here, this location, and it searches in the directory for the file. If the file exists, it opens, and this file is being taken from the secondary storage. Secondary storage is the hard disk. So this opening of the file is being given to the kernel memory, right? And from the kernel memory, it immediately informs the secondary storage, and wherein you have a file control block. From the file control block, it checks the detail from where that file is available. So these are the different directories. So from the directory, it goes to the kernel memory and it opens. And so this is my user space wherein I read the file, contents of the file. So in the kernel memory, I have an open file table, and per process open file table and a system wide open file table. In the process open file table, this index it will be having only the index values, and that index value reads to the system wide open file, and from where it goes and checks into the data block and with the help of a file control block, and from the data block it takes all the information from the file control block and it reverts to the system wide file table. So this is how an in-memory file system structure looks like. Now let us see how the files have been partitioned and how the files have been mounted. So if I want to mount, because mounting and unmounting is a concept that has been used in the Unix operating system. In the Unix operating system, if I want to open a file or if I want to access a file, I am supposed to mount that file, and after closing that file, I am supposed to unmount the file. So mounting and unmounting is a task that has been taking place in Unix operating system. So now how to partition a file system? We have a raw partition or we have a formatted partition. What is a raw partition? A raw file system is a file system that does not have any sort of partitions. Whereas a formatted partition is, as I said in one of our earlier lectures about a hard disk. In our hard disk, if you are going to have 500 GB space, wherein for C drive, when you are going to allocate 250 GB and 100 GB for D drive, 100 GB for E drive, then you have partitioned in such a way that you have sliced your disk in such a way that every C drive and D drive acts as a mini disk. So that is called as slicing, that is called as partitioning. If you are not partitioning, if you are going to use the entire 500 GB, then you are using a raw disk. So here a raw disk is just a sequence of blocks with no file system at all. wherein with no partition. And partitioning is, if you're going to have a file system, the different file system used in Windows is FAT file system and network file system. So even if you're partitioning or not, you will be having a boot block. Boot block is required to boot the files, boot the operating system. It contains all the details of the BIOS details, right? So boot block can point to boot volume or bootloader set of blocks that contain enough code to know how to load the kernel from the file system. So if I want to start an operating system, switch on a computer, immediately you could find a BIOS. With the BIOS only, BIOS contains the, that is, it needs to have a bootloader. One and only with the help of a bootloader, it can, after booting only, it can go inside an operating system. Now we will see how it has been partitioned. The root partition. In the root partition only we will be having the booting. So it contains the operating system and other operating systems and other file systems. So it has all the boot time loaders, bootloader information is available inside this root partition. At mount time, the file system consistency is checked, whether all the metadata are correct. If it is correct, it will mount the table and it will allow the access. If it is not correct, it will fix the error and then it will see to that it is getting mounted and the access is being allowed. So this is how the partitioning and mounting works. Now let us see the implementation of a directory. So how the directory is implemented. First one is using a linear list. In the linear list of file names with pointer to the data blocks. This is very simple to program, but it takes more amount of time to execute. This is the first way of implementing a directory. Second way is with the usage of hash table. What is a hash table? Hash table is a linear list with hash data structure. It decreases the directory search time, and the problem is it may end up with collisions. Collision is a situation where two file names have the or gets to a same location is called as a collision. And then it is only good if entries are fixed size or use chained overflow method. Then we have a third allocation method, they called as a contiguous method. What do you mean by contiguous? What is the difference between continuous allocation and a contiguous allocation? Say for example, if I am going to say I have an array or I have a value of 1 to 10. So I have space from 1 to 10. I am allocating some 10 people to sit on that particular space. If I am going to call from 1 by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that is continuous. Contiguous is I have allocated 10 space, out of which I am calling only 1, 4, 7 and 10. So I am picking out randomly and then calling. That is called as contiguous allocate memory space. Wherein all my 10 spaces is only for me for access, but I have the resources available only in 1, 4, 7 and 10, which means with 4 resources itself I am able to get all the details. That is called as contiguous. So array allocation is also contiguous allocation. We will see with a diagrammatic image. So these are said to be my different directories, wherein the files I have stored only in these two directories. So in 0 and in the first location I have stored, and 6th and 7th I have stored, 14 to 16 I have stored. So 0, say for example my file name is said to be count. So this gets stored in 0 and 1. So the start is 0 and it is going to use two different locations. So length is 2. And if I have a second file called f, it is also using only two locations, wherein the start value is 6. And since it is doing two locations, 6 and 7 will be occupied. And if I am going to have a file called as tr, wherein it uses 3 locations, so the start value is 14 and it uses 3 locations. So it will get segregated in 14, 15 and 16. And then if I am going to have a location called mail, wherein the start value is 19, and if it is going to use 6 locations, then from 19 to 24 it will be stored. So mail starts with 19 and its length is 6. And if I'm going to have one other file by name list, if its start value is 28 and if it is going to have a length of 4, then it means that 28 to 31 is said to be, it is a place where it gets stored. So this is called as a contiguous allocation of disk space. Now let us see the extent based systems. So in the case of linking, if I want to have a linked memory, how it gets stored? So in the case of newer file systems, like as I said, ZFS is a file system that has been used in the zettabyte file system is used in Solaris, or some other newer file system, something like Veritas file system, or otherwise called as VFS. They use an extent based system. In this extent based system is a contiguous file system, a contiguous block of disk, wherein extents are allocated for file allocation. The file consists of one or more extents. So next is the file consists of one or more extents. So next is the linked allocation. In the linked allocation, each file, a linked list is been created, has a linked list of blocks. So now let us see in a diagrammatic fashion how it works. So this is a linked allocation wherein I have a file by name Jeep, and it is being stored on a contiguous way, but there is a link. This file starts at the position 9. So that is the reason it says that it starts at 9 and it ends at 25. So these are the areas wherein the file contents have been stored. So from 9, what happens? It goes to 16, and from 16 it goes to 1. From 1 it goes to 10th location, and from 10th location it goes to the 25th location, and it ends over here, and that is the reason it has been said as it starts at 9th location and it ends at 25th location. So linking all these locations is called as a linked allocation. See how this linked allocation works in a block and pointer. So in the block, what it needs to contain is, it needs to contain the next location where that particular file gets stored. That is called as a linked allocation. So in this linked allocation, how the files have been stored? This block contains a pointer value. What is a pointer value? This pointer value uses or helps to locate where the contents have been stored on the memory. So this tells us, this pointer value, when you see with respect to this figure, it starts from pointer number 9 and it goes to the 16th block, 16th value, wherein this 1, it should have the value of this 16th location. So this pointer holds the next block value where that contents have been stored. So this is how it gets stored in the linked, this is how it gets allocated, and this type of allocation you call it as a linked allocation. So in our Windows file system, we have a FAT allocation method. The FAT is nothing but file allocation table variation, wherein we have a beginning of volume which has a table which has been indexed by a block number. It is much like a linked list, but it is faster on disk and cacheable. Cacheable is a bufferable, and it has new block allocation is pretty simple in Windows when compared to the other allocation types. So with this, we will summarize whatever we have seen in today's lecture. So we have seen about the file system structure, we have discussed how file systems are implemented, we have learnt the directory implementation, and we have seen the allocation methods. Now we will find out what are the possible questions that could arise from today's lecture. Question number 1, what is a file system structure? Question number 2, how are file systems implemented? Question number 3, what is a file control block? Question number 4, what is contiguous allocation? Question number 5, what is a linked allocation? So with this we come to end of this session. We will see more topics on operating system in our forthcoming lectures. Thank you.